Hello guys, in this new video I'm going to show you all you need to know to create your ICO and token contracts. You need the token contract, the tokens with the ICO contract. So first we will start with the ICO, with the token contract. The token contract is an Ethereum ERC20 token. ERC20 means that it's a specification. They define specific features for the contract. It's just a contract with some functions that allow that contract to be able to be used as a token, as a currency, as a cryptocurrency. So let's get started, and I'm going to show you how you create a token contract. Here I have an ICO project. Let's just remove this because right now we don't need it. Let's remove this. And then let's add a new folder. Go to your desktop and create a new folder called token. Then go open a terminal or a command line, go to that folder and initialize truffle with truffle init. Then do npm init /y. This means this just creates the Node.js configuration for keeping the packages and so on. It's just this package JSON file which contains all your dependencies, all your libraries, everything you need for this project. Then let's after this let's install another dependency called Zeppelin Solidity. The slash uppercase S means that we want to save that dependency in our package JSON file, so we can install it later if we lose that package or something, or if we don't have it in the node modules. So as you can see, you have this Zeppelin Solidity folder which contains the contracts from Open Zeppelin. Open Zeppelin is just a company where they develop contracts, open source contracts, for helping people develop tokens, contracts, making, they make useful libraries. SafeMath is one of the most famous ones, which allows you to make secure mathematical calculations with a library. Let's start creating this token. So go to your contracts folder and create a new contract called token.solidity. Then let's specify the version of Solidity, 0423, and save it. Now we want to import some libraries from this Open Zeppelin, from this Zeppelin Solidity, who will help us, some libraries that will help us create this token, because a token is easy to make, but you need to have, people usually don't create the tokens from scratch. You have a lot of libraries like this where you can just take the code from other use cases and use it in your project. This is the best, most secure way for creating a token that is good for people. You can see that we have a contracts folder and then a token folder. Inside that folder you see ERC20. There's also ERC721, 823. These are just different versions, and these contracts are not yet established, so they are not the official version of the token. The main version is this ERC20. You can see that we have the basic token. There's different variations, but the basic is this one. You have to basically take this ERC20 basic and ERC20 Solidity and import them to your contract. So simply copy this code, this contract, and then go here and paste it. This is the basic functionality. You can see then that we have a total supply function, a balance of, a transfer. In a ERC20 contract you have some functions like balance of a user, how much balance that user has, a transfer function for transferring tokens from from a user to another, and that's pretty much it. You have these are the two main functions. Then you have allowances, but they don't really matter right now. They're just used for more complex projects. The total supply is the total amount of tokens that are available at that moment. Let's copy the ERC20 Solidity. It has some advanced functions like this. The allowance is just a function where you can allow some of your tokens to another user. Let's say that you have 100 tokens. You execute this function to your user B, and that user will be able to use your tokens like his without at any point. You can allow him 10 tokens or 20 tokens. You don't lose those tokens, but he can use them like his own tokens. You know what I mean? It's just like an allowance. The transfer from is just a function used to transfer, but from another user who has allowed you some tokens. Instead of using the transfer function, which is this one, to transfer tokens to another user, use a transfer from if you are using the tokens from another user because you have an allowance. You know what I mean? It's complex, but it's possible. Approve. I don't really know what is this function. Yeah, approve is this function to allow the tokens. Allowance is just showing you how many tokens you have available. You see that the owner and the spender, it returns how many tokens that user is allowed to use. Approve is the function that you execute to execute the allowance, to give permission to another user, how many tokens you want to give and to what person, to what address. Now these are the basic functions from an ERC20 contract, an ERC20 token contract. Now you usually want to add some, depending on what you're creating, you want to add some different functions, but the main ones are something like this. You have the basic token, which is just an implementation of what we just saw. Yeah, let's take this basic token also. And safe math, you can see that we're using safe math, so it's great to import it. It's a good idea to import it. So go to your math folder and import safe math by copying the entire code. You can use the import keyword, but I prefer to copy it manually because it gives you that clarity of knowing what is going on, and you can see all the contracts on the same place, because the token is just one contract with all the functions. So you want to have all the functions there. You can import them, but it's more difficult to deploy them because you have to deploy one contract then another, and it's not the best option. Okay, let's go to token back again and use the basic token. Just copy all this. The basic token is just creating the body of all of these functions. As you can see, these are interfaces. These are functions without body. They are used to define the functions that we will use later on, but they don't have any body. They are not completed. They are empty, as you can see. So we have to define them with this basic token and standard token, this one, which is just a more complex variation, which implements the transfer from function, the approve, increase approval, just some useful functions. You don't have to worry about that. Just copy the contract and paste it in your code. Now let's take a look at what we have here. You can see that we have the safe math library for making mathematical calculations, which is used by the ERC20, the basic token. We have the ERC20 basic, which is just the interface of the functions. This is important for using later. I mean, you can create the contract on your own. You can define the total supply, the function, the transfer function, the balance of function, the approve function, the allowance, but it's very complicated and you can make mistakes because it's a delicate process. People can exploit that contract and use it for their own benefit. So it's important to use these libraries that are already tested from SafeMath. That's why we are importing these contracts from SafeMath, from OpenZeppelin. I mean, you have ERC20, you have the basic token, which is just the implementation of the ERC20, and the standard token, which is a more advanced implementation of the ERC20, which implements the proof, the transfer, the allowance, and so forth. Now let's take a look at another contract. Safe, these are not important. Pausable. This is if you want to make the contract pausable, to pause the contract whenever you want, so that people don't use it to block all the transactions and so on, but that doesn't really matter right now. Now this contract is called token.solidity. So now the next step is to create a new contract called token, which is you have to use the keyword is to import, I mean to inherit the standard token. You want to inherit this standard token because it includes all the functions from ERC20. These functions are the ones that allow people to see the balance, to see how many tokens are available, the name of the token, and all that good stuff. Now, in a token you want to define several things. First, the total supply. How many tokens there are in total. This is, you can define that after the ICO or before the ICO. I like to define the total supply before the ICO, so let's keep that in mind. The name of the token, you need a name. It can be called Bitcoin 2 or whatever. You need a symbol. A symbol is just the 3-letter name of the token for finding it easier. So like if you are creating the Bitcoin token, it will be BTC. This is just an example. You need, what is the total supply, the name, the symbol, and that's it. I mean, the symbol. I think I'm missing something, but I don't remember exactly. Let me check one of my contracts. This is a contract, Drops. It's a contract from Fluid.ai, a company that I worked before in the past, and they have this SafeMath library, ERC20 basic. This is a real contract that I deployed on the network. Right now it's working. It has the same contracts as you can see. Standard token, the ownable, which is to create an owner. This is not necessary. The pausable, this is to pause the contract if you want. It's not necessary. These 3 are optional, so don't worry about them right now. And the name of the contract, you have the name, the symbol, the decimals. Decimals is very important. Decimals is how many decimals you have in your contract. That means that if one token is 1, you can have 2 decimals, which means that you can divide that token in 100 pieces, like euros. Let's say that 1 euro is 1 euro. If you have 2 decimals, it will be 0.00, I mean 0.01, like this, 0.01. That means 2 decimals, because you have these two numbers after the unit. You see, 2 decimals. That will be 2 decimals. Ethereum has 18 decimals. 18 decimals. This means that the smallest unit is like 0.0000 until you get to 1. It's called the way. And these are 18 decimals. They want to do it that way because the price of Ethereum can go like crazy, and if you have to allow people to divide each unit of each ether into smaller units for making possible to transfer precise units and so on. Bitcoin has 8 decimals. So you can divide a Bitcoin in 10 million units, 10 million smaller units, which are called Satoshis. Okay, so what else do we need for this token contract? You have the initial supply, this is optional, and that's pretty much it. These are different functions for the contract. So let's define all of this. The total supply, it's not defined in any of these contracts. There's this function, the total supply function, but it is not defined. We have these balances. This is a very important mapping, because this mapping says what the user and the amount of tokens he has. This is the most important variable of the entire token, because it says how many tokens each user has. It's just a mapping with the balances of each user. Total supply, I don't know what is this, we don't really care about that. Allowed is just another mapping for that, don't worry about that. Let's define the total supply. Total supply is a uint called total supply, which is a number. Let's say we want to have a total supply of 100 million tokens. So we say 100E. Well, first let's define the decimals, because we will need the decimals. Let's say that I want 3 decimals for the token. 3 decimals, you can divide a unit in 3 smaller pieces. I mean, in a million different pieces. In total supply, I want this to be a million. If you have 3, a million is 100. I mean, 100 million is 100 to the power of 6. So 100 multiply 100 with 6 zeros, that is 100 million. But because we have 3 decimals, we need to add 3 more, because we are dealing always with the smallest unit. Every time you make a transaction, you are dealing with the smallest unit. Instead of having this, instead of dealing with a number like this, you are dealing with 1, you know, because we're using the smallest units first. We don't really have decimals in the contract, because you cannot have unprecise transactions. So for instance, if you want to send 1 token, you're actually sending 100 smaller pieces. 100 smaller pieces is a token. So keep that in mind, because it's an important concept and it's confusing. So that's why we are defining 100 million with 100 to the power of 9, because we need 6 zeros plus 3 zeros to define exactly 100 million tokens. That is the total supply. Now we need the name. The name is a string, which is, let's say, token X. The symbol, which can be a string. It can be a string, a bytes, 32, but everybody does a string. So symbol, name symbol is TKX. That's the symbol that I just created. You can write 4 or 5 letters, even 6, doesn't really matter, but people prefer to just use 3 letters for defining the symbol. It's easier to find, easier to understand. And that's it. We have decimal, the total supply, the name, the symbol. Now, when you create the contract, when you deploy the contract, all this is set up, all this is defined, but you want to get all those tokens to somebody, because you want somebody to have the tokens to distribute them later. You know, there are different ways to distribute those 100 million tokens of the total supply, but what I usually do is I create just the constructor. I don't know if this is, because there's a new syntax for the constructor. I don't know if this is the exact same syntax. So now, instead of using function token, which will be the constructor, you use the keyword constructor. Let me check the Solidity documentation. Every time you have a question or something, go to the Solidity documentation and check the code to see what is the way how you actually do something. Constructor, you can see it is called like that. Okay, it's as simple as this. What is this? The constructor. What we're going to do is set up the message sender. I mean the balances. Balances is if you remember, balances is this variable where you define how many tokens each person has. In this case, I'm defining the balances of the sender. The person that created this contract, the sender, will have a balance of the total supply. This means the one that I'm creating the contract, I'm getting all the tokens to distribute them later. That's basically what I say. The balances of the sender is equal to total supply. And now that's the basic contract. You can use it right now. You can put it on Ether. I mean, let's deploy this contract and see how it works. Let's copy this. Let's go to Remix. If you remember the block contract, let's deploy this thing. Let's change to the, well, let's use the new version of Solidity, which is 24. As you can see, I'm getting an error there, so I need to change that thing. Okay, total supply already declared. Somewhere there's the total supply. I don't really like this because they are creating a function called total supply where they are returning the total supply, but I don't really like that, so let's remove this. You can remove it if you want. So let's reduce the size of all of these contracts for seeing everything clearer. Now the total supply, what is going on here? 55. Okay, we have the total supply here. Let's remove this also. Now, one important thing that I forgot is that you have to set up all of these variables as public so that people can get the values. You know, public. If they are public, they have get their methods for getting the value freely without any restrictions. Okay, that's the contract. As you can see, this is our part. We are defining the decimal, the total supply, the name, the symbol, and the constructor. All of the other things are just the essential elements of an ERC20 contract. You need all of this for creating your contract, but you don't really modify this if you don't want. If you don't want to modify them, you can keep them as they are. You just have to create all this section for the token. Later we will see how to create the ICO token, the ICO contract, I mean. Let's deploy this. Select. It's important that you select. Well, first you have to log in to MetaMask, and we will use Ropsten. So let's reload this. Now select your token, your contract you want to deploy. This last contract that we just created. Here you're selecting which contract to deploy. In this case it is token, which is basically using all the previous contracts. It's inheriting all the previous contracts from here, from the is keyword. So let's deploy this token contract. Click on deploy and submit. Wait, let's try again. Increase the GUI because it is 0 right now, the price of the gas. And let's wait for this to process. Let's wait for this to complete the transaction. Okay, the contract is deployed, the token contract is deployed. Save the address. Remember, I'll always save the address whenever you're creating contracts and so on. Now in Etherscan you can do a very interesting thing. You can go to your you can search for your contract here. Just paste the address of the contract, and you can see that there is nothing there. Contract token. Okay, if you change this to token, you can see the token. You can read the contract. Well, let's make this possible. Let's verify the source code. This is important. You have to verify the contract for allowing people to read the contract and see that it is actually there. Token content name token compiler. We're using the 4 version. Yes. Optimization, no. Remember to select no. This is important, otherwise this won't work. So go back here. First let me update my file, save all the changes, then copy all of this and paste it over here. Now we don't have any arguments in the constructor, so leave this empty. Don't worry about this, this is not necessary. And then verify and publish. We're just verifying the source code to allow people to see it from this open website from Etherscan. Etherscan is the main website that is very famous. It's basically the main website for learning about transactions and so on. Okay, there is a problem here. It looks like we are not using this version. Yes, we're using this commit, which is a different version. So let's go back. Commit. It is commit E67. Commit E67. Basically, what is happening right now is that I'm trying to verify the contract, but the version that I used for compiling this code is this 0.4.24 commit whatever. Let's change that to 22.3. I mean 223. This version. Then change this to 23 and deploy the contract again. Let's remove this one and deploy this token contract. Increase the gas price because right now it's 0 for no reason. And wait until this is processed. Copy all of this and paste it in your source file. We have to wait for this to process. Okay, here we have the token contract deployed. Let's copy the address, paste it somewhere safe. Now let's do the same thing. Let's go to here to search. Right now have this page open, so let's paste the address. Let's change the version here, and let's change this compiler, which is this one, 0423. And verify and publish. Every time you make a contract, a token contract, or an ICO contract, you want to verify and publish the source code on Etherscan, because people will want to see the contract and it gives you that trust. It increases the trust from your investors. It's really important. The contract has appeared. Okay, let's use the version 2.0 of this verifier. Let's copy the code, paste it here, token compiler. This version 2.0 is just, it is telling you if there are any errors. It is more precise. Okay, as you can see, the code is verified. There's this successful message. You can go to your address, to your token address by clicking here. You can see the address. The contract address is this one, and you have the code. You also have the token contract. You can see they detect that it is a ERC20 contract. They detect that it's a valid token contract, and you can click on here to view the token information, like total supply, holders, and so on. I don't know why this is empty. It shouldn't be empty, but don't worry about that. balance of, let's check the balance of my account. Copy the address and paste it here. You can see that I have all the tokens. I have 100, well, basically 100 million. You can see that there's 100 million of tokens right now, but we defined 100 million with 3 decimals. That's why this is the right number here. They're detecting the decimals and everything is correct. So that's it. Now you know how to create a token contract, how to verify the source code for checking the code online. This is really helpful if you lose the contract, if you don't know, if you lose the code or something, you can go back to this page and check the contract. You can copy and paste that information back again. This is really useful. Now I'm going to show you how to create an ICO contract for selling those tokens.